Good morning, Doctor. My name is Tanchunda, and today I would like to present about our PSTA Project 2, which is Statistical Analysis of Robbery Trends in United States. Our group member include Tanchunda, which is me, Liminda, BOYU, and OMAR. So my main role in this presentation is to present about the introduction part and also the dataset part. So let's begin with the introduction part first. The crime statistic are essential for shaping the public safety strategies and also allocating the law enforcement resources. In this project, we investigate the robbery patterns and current performance in the United States. We have analyzed the data over a 43 months period from June 2020 to December 2023. And you're using the reports from the FBI Uniform Crime Reporting Program accessed through the Crime Data Explorer. Our goal was to uncover the trends in robbery incidents, detect the statistical difference across year, and explore the relationship between the robbery count and the occurrence rate. So for the dataset, was sourced from the FBI Uniform Crime Reporting Program via the Crime Data Explorer. It provides the monthly national level data on robbery incidents and occurrences covering for 3 months from June 2020 to December 2023. And there are three main variables that we have used for the analysis. First is the robbery, which is the total number of robbery cases reported each month. And the next one is occurrences, which is the number of those cases that were solved. And the third one is the time variable, which is the time index, and is a sequential number from 1 to 43 that used for the time-based analysis. And for the data processing process, we have separated it to 3 steps. The step 1 is reshaping data. So we have flipped the data so months can become row and the crime becomes column. This means each row now represents a specific month, and next, the new columns were then given a clearer name, which is United States and United States clearance. The month's information, original row name, was moved into a dedicated months column. And the step 2, which is convert data types. The uniform states and United States clearances column, which are text, were converted to numeric values and renamed robberies and occurrences. This allows for calculations and statistical tests. The month column was used to create a proper dates column, and this we do for showing trends over time. And here is the code that we have used for the convert data types part. For step 3 is for the cleaning and indexing. We have removed any rows where the date and robberies data was incomplete. This is to ensure our analysis only use the valid records. And furthermore, a sequential months index was added to represent the passage of time numerically for regression analysis. And lastly, a year column was created from the date for easy grouping and year-to-year comparison. And here is the code for cleaning and indexing. And here is the dataset before the processing, and here is the dataset for after the processing. And that's all for my part. Thank you, Doctor.
Hi, Dr. Zian, and this is my part of the project. So my name is MOHAMMED. My teammates are Tanchunda, Limingda, and BOYU. And our project focused on the statistical analysis of robbery trends in the United States between the years of 2020 and 2023. And so the contents of my part of the presentation is the T-distribution analysis and the conclusion of the project. So let's start with the T-distribution analysis. So the purpose of this test was to determine whether there is a significantly different difference between the mean number of robberies before and after the year of 2021. So the variables used were both numerical. The first one was the robbery counts before 2021, and the other was the robbery counts after 2021. So the hypothesis statements for the null hypothesis was that there is no significant difference between the two means, and the alternative hypothesis was that there is a statistically significant difference between the means of the two groups, which is before and after 2021. So after doing the calculation, we got the statistic of t equals 2.117 and the critical values of plus minus 2.3721. So what this means is that, as you can see here in the graph, the blue lines mark the critical values. Whatever is out there is marked with red here and there. As you can see, these are the rejection regions. So if the test statistic falls outside of this range in the red regions, it means that we reject the null hypothesis. But if it falls inside this, between the two blue lines, it means that we fail to reject the null hypothesis. As you can see, in the interpretation of the results, the test statistic is 2.117, and this is inside the acceptance range, which means that since it does not fall within the rejection, and we fail to reject the null hypothesis, which means that based on this test, there is not enough statistical evidence to conclude that there is a significant difference between the number of robberies before and after 2021.
Good day, Dr. Izian. My name is Liminda from Section 5. Today, I would like to present the Project 2, which is Statistical Analysis of Robbery Trends in the United States. In this video, I will conduct two data analysis, which is the second one and the third one from our projects, which is correlations analysis and regressions analysis. We proceed to the correlations analysis. So the purpose of this test is to examine whether there is a statistically significant linear relationship between the robbery counts and the clearance count, the variable used. The dependence variable is robberies and the types is numericals, and the second one, independence variable, is clearance. The types is also numerical. We proceed to the hypothesis statement. The null hypothesis states that there is no linear correlations between the numbers of robberies and the numbers of clearance, while the alternative hypothesis states that there is a linear correlations between the numbers of robberies and the numbers of clearance. So this picture is the result of our R programming for this correlations analysis. We move to the next section, which is test statistics. The process correlations coefficients is 0.933, and the p-value for this analysis is 2.181, times 10 to the power of negative 19, and the significance level for this test is 0.05. Next, interpretations of results. The correlation coefficient R is equals to 0.93, which indicates a very strong positive linear relationship between robberies and the clearance count. The p-value is significantly smaller than 0.05 alpha levels, which indicates that the correlation is statistically significant. We proceed to the last part of this analysis, which is the conclusion and discussions. Since the p-value of 2.181 times 10 to the power of negative 19 is smaller than 0.05, we reject the null hypothesis. The analysis shows a strong positive correlation between robberies and clearance, suggesting that as the robberies case increase, clearance also tend to increase. This may reflect effective law enforcement response that scales with the crime's level. Let's proceed to the next analysis, which is regression analysis. The purpose of this test is to determine whether if the numbers of clearance can be used to predict the number of robberies and to quantify these relationships. Let me explain the variable used. First, the dependence variable is the robberies, and the type is numericals, while the second one, the independence variable, is the clearance. Type is numerical. Let me explain the hypothesis statements. The null hypothesis states that the number of clearance has no significant linear effects on the numbers of robberies, while the alternative hypothesis states that the number of clearance has a significant linear effects on the numbers of robberies. And you can see that there is a picture here, and here is the result of our R programming for this regression analysis. Next, we proceed to the test statistics. The R square value is 0.054, and the F statistic is 2.321. The p-value is 0.135, and the significance level for this analysis is 0.05. Proceed to the interpretations of the results. And R square's values of 0.054 means that only 5.4% of the variations in the robbery counts is explained by the linear model with times. This indicates a very weak linear relationships. Conclusions and discussions. Since the p-value of 0.135 is bigger than 0.05, we fail to reject the null hypothesis. Although the regression lines are just a trend, the low R squares value shows that the death variables alone does not meaningfully predict the robbery levels. Other factors like this have a strongest influence on robbery trends over the time. And that's all for my part. Thank you.
Thanks, Judge, and good evening. My name is BOYU. I'm responsible for the part 4 analysis of variance. And for this part, our purpose is of test to compare the mean numbers of robberies across multiple years. And the variables used is dependent. The variable is robberies, and it was a numerical type. And for the independent variables year, we use a categorical. So we use 2020, 2021, 2022, and 2023. So we got the hypothesis statement, and after that we get the F value and the P value. As our significant level is 0.05, so we will refer to this, got the value and compare to the F table. So after that we reject the null hypothesis. There is a strong evidence that the mean numbers of robberies differs significantly across year. This variance could be due to policy changes. And now I'm going to show my R programming. So here is our library input, and here is our load data and transport and receive the data. And after that, it converts the variable and fill the invalid rows and come to the analyze first question. And next to the regress. And after that, we create the G-plot for the regress. And after that, we come to the ANOVA to calculate and output the graphic. So after that, we got this plot and save this plot to the PDF. So now I'm going to demonstrate my code. So we can see that here is our datasheet, and after we open the datasheet, it will directly output the graphic from analyze 1 to analyze 4. Okay, that's all. Thank you.
Statistical techniques we learned during this course in order to analyze real-world data and do data-driven decision-making. So, we started with choosing the dataset, and then we applied and did 4 different tests in order to draw conclusions. So the 4 different tests were the t-distribution test, correlation test, regression test, and the ANOVA test. So as we discussed in the t-distribution test, we wanted to assess whether there was a significant difference in robbery counts before the year 2021 and after the year 2021, and we found that there was not a significant difference between the two counts, the two means. And for the second one, for the correlation analysis, we wanted to check whether there was a strong linear relationship between robbery incidents and clearances. And we actually found that there was a very strong positive linear relationship between the two, which means that as the robbery counts increased, clearances increased also, which means that, and can also show that the police forces and law enforcement scales and increases its effort with, the count volume. If the crime increases, clearances increases, and the opposite is also true. And next, for the regression test, we demonstrated that the clearances are a strong prediction of robbery counts. This is close to the correlation test in the, it gives the correlation test even more validation, because as we saw there, as crime increased and the number of robberies increased, the clearances also increased. And finally, we had the Innova test. For the Innova test, it compared the mean robbery rates across the 4 different years, and we found that there was a statistically significant difference between the 4 years, and thus we rejected the null hypothesis, which confirms that the robbery rates did not remain consistent and instead varied year from year. It was a different robbery count each year. And so, in summary, like I said, we really learned a lot of skills and learned how to apply the skills we learned during this.